Hey y'all, here is another round of video notes for you. We are moving away from the foundational components of looking at how we explain behavior. Now we're going to start looking into how it is that psychologists ultimately gain information on behavior. How do we attempt to establish research? This is going to be broken down into two sections ultimately. So what you're tackling for me right now is what we call descriptive research. So the whole entire point behind this kind of research is to describe, hence the term, or explain certain characteristics of behaviors that are being seen. However, there is no cause and effect relationship that's established with any of these. And that is a really, really, really important component to keep in mind right off the bat when we're covering this content. Descriptive research doesn't give cause and effect. And if within the field we want to be able to understand what behaviors are caused by what things or vice versa, we have to establish cause and effect. And the only way that we can do that is through experimentation. But that is for a lesson for a different day. So let's get into correlation, one of the first types of descriptive research pieces out there. This is when we attempt to measure the relationship between two items or variables. It's really easy for kids to get correlational components confused with experiments because they see the word variable in correlation and they see the word variable in experimental data too when they're talking about independent or dependent variable. But make no mistake, correlation isn't being able to assess a causal connection. You're not manipulating anything in correlational studies. So it's just how well do these variables move together with one another or in opposite directions. If they increase together or decrease together, so if they go in the same direction together, they're considered a positive correlation. So if you look, for example, the number of gallons of gas that's pumped is positively correlated to the cost of gas. The more gas you pump, higher your cost goes, and vice versa. The lower the amount, the lesser the cost. Now, on the other side of this, you got negative correlation. Negative correlation simply implies negative because they're going in opposite directions. It's very easy for kids to get negative correlation confused with this portion of a positively correlated relationship because they see decrease, so they automatically assume, ooh, it's got to be negative. But the reality is, if it's going in the same direction, it's always going to be a positive correlation, the two variables. And if they're going in opposite directions of one another, you're dealing with something that's negative. So let me give you an example of this. I'll move this out of the way for you so that way you can see what I'm talking about here. The miles that's traveled by a car is negatively correlated to the amount of gas left in the tank. So the more that you are using your car, the more gas you are taking out of the tank, so obviously it's going lower. Okay? So see how they're going in opposite directions of one another. That helps you to identify negatively correlated relationships. We put our correlational data on scatter plots. Okay? So scatter plot, that was thunder, and quite impressive at that. I guess apparently it's about to rain in a second. Scatter plots are graphs that we use within correlational data that take the points with which we're looking at these relationships and place them in a visual manner, okay? So it helps us to see a slope of the variables that we're looking at to see the direction and the amount of strength to the relationship. So the closer that they are to one another, you can see this right here, for example, or this right here, these are perfect relationships, okay? The closer they are to a perfect line, the more closely connected they happen to be. The strength of their relationship is exponentially stronger. If it's all over the place, then that means that there is no real relationship between them, okay? Now let's talk direction. If you have a perfect positive correlation starting from the bottom left, it goes up to the top right. If you have a perfect negative correlation or just a negatively sloping a correlation in general, it doesn't have to be perfect. It can be, you'll see this when we tackle the correlational coefficients, it can be other numbers. And the same goes for positive. It's going to start in the top left, make its way down to the bottom right. It's entirely possible that you could be asked questions about scatter plots with visuals like this on the AP exam. So you want to make sure that you understand the scatter plot data and this guy here, correlational coefficient. This is our statistical measure to see the degree of relationship between the variables that we're studying, okay? So the number itself is going to be indicative of the strength. So you heard me talk about that just a second ago. It's going to be from a range of 0 to 1. 1 means that it is a perfectly correlated relationship. If it's down towards 0, it means there is no relationship. It's incredibly weak. Okay? The direction of the relationship will be signaled either by a positive or a negative symbol in front of your correlational coefficient. So if it's a plus sign, that means that you have a positive correlation, meaning they're either going to increase or decrease with each other. If it has a subtraction sign or a minus sign, then what that means is it's a negative correlation. So they're moving in opposite directions of one another. Your number is always going to fall either between -1 or +1, okay, because that's what we're looking at in terms of the range for these, because it can't go anything below that point because your relationship is within 0 to 1. And the higher the number, the stronger the relationship. We'll do a couple of questions on this piece in class to kind of help you guys figure out how it is that we can read certain relationships in correlational data because of the coefficient. Okay, but just to help you for yourself, for general examples, to help encode this a little bit better for you, if you look at this first number here, 78 hundredths, you can tell that it's pretty close to a perfect 1. So we would say this is a pretty strong relationship, and because we have this symbol here, the minus sign, we know that it's negative. Whoop, sorry. So then for our 5 hundredths, this is going to be pretty weak because it's darn close to 0. And we know that it has the plus sign here, so that means that it's a positively weak or a weak positive correlation. Right here, this one's going to be a little dicey because it's right towards kind of the center. We know it's a negative correlation, but since it's right in the center, we would say it's moderately weak because it's closer to 0 than it is closer to 1. And then you got this guy right here, 92 hundredths. Once again, we see the plus sign there, so we know that it's a positive correlation. And since that's darn close to 1, we're going to say that this is a very strong positive correlation. So again, we'll do some examples of this in class as well to help make sure that it's sticking for you. Because by nature, I'm not a math person or a stats person either. So for those of you guys that are sitting there saying to yourself, I don't know what I'm doing, I was with you before I started having to take this course. Another way to take a look at this stuff is to look at scatter plots showing relationships between the variables themselves, okay? So what this research attempted to do was establish a relationship, if there was one, between height and temperament. I should clarify for you that when we're referencing temperament, what we're talking about is your emotional reactivity to something. So how well you respond emotionally to things. Are you a calm person by nature, or are you someone who has a tendency to get very anxious and worked up over things, particularly if they don't go according to plan? So when we look at the direction of all of this here, I'm going to bring you back to the images of the scatter plots that we first presented you with. So you'll notice that there is a positive correlation because they're angling from bottom left to top right. They're not all over the board here, but at the same time, they're not super scrunched together in terms of a perfect kind of correlational link. So we would actually take a look at this and say there's a moderately positive correlation between your height and your temperament. So when we look at this in terms of the x and the y axis, you can see that the taller that you get, the more that your height increases, the higher your temperament score. So apparently us short peeps like myself aren't so great when it comes to rolling with the punches according to this data. But that's how somebody who doesn't think like a psychologist would assess things, because one of the things we'll discuss in a second is that correlation doesn't mean causation. So one shouldn't jump to the conclusion that if we're short, then that means that we have that shortness causes our emotional reactivity in a situation. And we'll touch on that in a bit. Let's talk illusory correlation, okay? You gotta be careful because illusions can be present when it comes to seeing relationships between two things, even when none exists. Essentially, what an illusory correlation gets at is what we believe to be true is true. So think about a superstition, for example. Let's say you're a hockey player and you have some underwear that you wore and you guys won. So you thought that to yourself as you were getting out of all of your gear and you were stripping down and all that to get yourself into some comfy clothes after your game or your match. Hey man, like these boxers must be real lucky. And so as a result of that, you say, well, I'm going to keep wearing these boxers every single time. that we have a game and we're going to see if our winning streak goes. Okay, so you start to see something that's there that in actuality isn't there at all. So you have to be careful when it comes to that illusory component, so that way you don't draw conclusions that could lead you astray in terms of your research. As you heard me say before, correlation doesn't mean causation. So just because there is a relationship between the two things doesn't mean that one makes the other true. For example, men who've been married for 50 years or longer are bald more often than not. That doesn't mean that being married causes you to go bald, okay? You have to be careful that even though a relationship can exist between two things, that doesn't mean one leads to or evokes the other. And so when we're doing assessments of research, we have to be mindful that unless there is an experiment occurring, there is no causational piece there. If there's just a reference to relationships in general or to variables in general, more often than not, you can go to a correlational piece to that, okay? So knowing that two items are correlated does not tell us that there is a causal relationship. If you didn't hear me, I'm saying it again. Correlation does not mean causation. If I'm saying it this many times, you ought to know that it is very, 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 very important. Kids stumble upon this piece all the time when we tackle it in this unit and further on as we go through the course. Correlation doesn't mean causation. Let's talk about one of your other possible options out there for descriptive research. We also complete naturalistic observations in psychology, so think Jane Goodall with her studies of chimpanzees where she lived in their natural environment with them. You got to be careful when you're doing these observations, though. You try as hard as you can to stay out of the way of interacting with your research types. Okay, so she, in many respects, would try to avoid interacting with the chimpanzees in certain circumstances and settings to make sure that that didn't impact their behavior that she was seeing. But what you're doing is you're watching the human or the animal in their natural environment, as it would, in theory, typically occur. Because one of the biggest problems for naturalistic observation is that when we know we're being watched, we can change our behaviors a little bit. If you think about, for example, teachers who are going to get an observation from their principal to assess their work in the classroom. If they know that they're going to be there, it's possible that a teacher is going to change up how they typically do their day-to-day routine with their students to make it more possible that they get a better score on their evaluation, right? And we would call that the Hawthorne effect. It's important to note that, and I'm trying to move myself out of the way here. I'll start down here just so that way you guys can see the stuff from the top and then move your way down. That doesn't negate the significance of what naturalistic observation can provide to us. You know, there is value to that where other methods can be disruptive. But if people know they're being observed, then that's obviously going to skew your findings. And ethically, you also have to tell people you're observing them. Okay, so that could have an impact on them knowing that you're watching them and altering their behaviors in kind, but you could offset that possible observer bias or issue with that by watching them for a longer period of time. So eventually they just get so used to you being there that it no longer seems to have an impact on their actions. Observations can also be distorted if the observer expects to see certain things. So with that observer bias, if you are looking for certain behaviors and then you see them, if you want to take it in kind of another looking back at illusory correlation, what we perceive to be true or are looking for to be true can be true purely just because we think it's there. So that's an important thing to recognize. Case studies are another type of descriptive research available in the back pocket of psychologists' attempts to study behavior. Case studies are going to be really intensive examinations of either one person or a very tiny group of people within a very specific situation. Oftentimes you'll see drug studies, for example, done in case study work first before they'll go out to clinical and more large general trials. They're very useful when something's new or complex or even kind of a rare circumstance. So Phineas Gage, for example, the gentleman who had a 10-foot railroad rod spike through his eye socket and out the top of his head, He's the reason we know what the frontal lobe is responsible for because he survived that accident. And so he was the initial presentation of that work on studying the frontal lobe. But what happened with Gage couldn't necessarily be applied to everybody outside of Gage's situation. Okay, so it lacks in representativeness. You can't generalize the finding of what's done for one person in a case study and apply it out to every single person within the human species. At the end of the day, though, it does provide some pretty valuable material for us to complete further research later on in experimental settings. It's important to recognize what can hold up surveys and make them kind of deficient or cons, if you will. The validity of your data is going to depend on how a question is worded. You can't tell me that there haven't been circumstances when you take a unit test, for example, and you don't really understand what your options are asking you, so you're like, well, I think I'll guess C. You understand what I'm talking about? The reality is how something is worded. If it's confusing to a person, they might give a not so valid response to that particular question within a survey, even though they're not trying to mislead you in terms of their responses. Representativeness of people's surveys matters too, okay? Ultimately, because that can sway the information that's given. So if, for example, you're trying to find out people's political leanings for the 2020 election, and all you're doing is putting out an internet survey, well, anyone who doesn't have the internet or access to the internet is then therefore left out of that research. So the findings aren't entirely valid in that regard because they're ultimately not representative of a larger whole. Other limitations to surveys is the willingness that people have to be completely honest. We saw this in the 2016 elections for President of the United States. There was an awful lot of shock and surprise when Donald Trump was elected. And when going back to take a look at a lot of the polling data that was done throughout that election cycle, come to find out there were an awful lot of individuals that said when they were surveyed they didn't intend to vote for Trump when they actually really did. They just didn't want to be judged by the pollsters on the other side for the fact that they were voting for Donald Trump. So the willingness of people to be honest can obviously skew your findings in your research. People may say what they think you want them to say, right? So if I'm giving a survey at the end of the school year and I say like, hey guys, you get the chance to be able to assess how we've done everything in this class, some kids might take that and say like, okay, well, she knows my handwriting and she recognizes it and she knows who I am, like I better say that you should just keep on doing everything that you've been doing. So well, when in actuality that's not really what we want to hear, right? We want honest opinions. It's still a great way to gather large amounts of information, though, and that's an important key thing. Purely from the surveys that you completed for me, I was able to assess all 80 plus of you when it comes to how much time you have on your hands, whether you're a prior AP student or this is your first year taking an AP course, whether you took Intro to Psych or not, where you live. I can tell based off of your zip code, so I know what middle school you went to, what elementary school you likely went to. So you get large amounts of info, which is great. You just have to recognize that there are certain downsides to surveys as well. And that brings us to one of our last options, which is the quasi-experiment or quasi-experiment. Either way you pronounce it, tomato, tomato, okay? These are studies where there's some control, so it's partially like an experiment, hence the quasi, that means partial, okay? But it doesn't include random assignment of participants, so it is therefore not a full experiment. It will not give true cause and effect, and that is an important critical piece to things, okay? So let's do an example here to help you understand how this could possibly work and not be like a full experiment. Researchers want to test the hypothesis that a pregnant woman's drug use is going to cause abnormalities in the developing baby. Well, you can't use random assignment of participants within this because you can't randomly assign who's going to take drugs and who's not. And further, it's not going to be a terribly representative sample because the only population that you're using is pregnant women. So men cannot be adequately assessed in here either. At the end of the day, you got to ask yourself, can you ethically do anything with this? Not really okay for you to expect a pregnant woman, ethically speaking, to ingest drugs that could harm the development of the fetus. But there are ways to ultimately, get around to completing this, semblance of control but not be able to do it with a random assignment. Okay, so the conclusions for quasi-experiments aren't as good, they're not as firm because they're not true experiments in and of themselves, but they do allow us to complete some research on topics that would otherwise be impossible to do because of that ethical standard that could be present there. We'll do another in-class activity that can go along with the quasi-experiment to help you better understand that guide too. So, hopefully you've been able to sit tight through this whole video as we've had to pause it for the various different noisy distractions from the weather outside. As is always the case, if you've got any questions, just let me know. But it doesn't hurt for you to go back and take a look at the video again to make sure that you've got everything that you need for this particular content.